Let us take this JEE Advanced question. Let capital N denotes the set of all natural number and capital Z denote the set of all integer. Consider the function fn maps to z and gz maps to n defined by, we have piecewise definition of fn and piecewise definition of gn. Let us try to write down for a few values. So domain of f is n. So let me take n versus fn. Let us make a table. N equal to natural number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the corresponding value of fn? N equal to 1. 1 is odd, so we will put here 1 plus 1 by 2, 1. 2. 2 is even, so 4 minus 2 by 2, 1. 3. 3 substituting here will get 2. 4 substituting here 0. 5 substituting here 3. 6 substituting here minus 1. 7 substituting here 4. 8 substituting here minus 2. 9 substituting here 5. So like that we are getting the value from the first function, and using the second definition, let us plot n versus gn. Here what is the domain? Domain is a set of natural number. So we will take a set of integer. The domain is a set of integer. So we will take, let us say 0, minus 1, 1, minus 2, 2, minus 3, 3, minus 4, like that. First, let us take 0. N equal to 0, what is the g value? N equal to 0, we will substitute here 3. Next, n equal to 1, if you take, we will substitute here n equal to 1, 5. N equal to 2, we will substitute here 7. N equal to 3, substitute here 9. So, we are getting a pattern here 3, 5, 7, 9. And minus 1, if you substitute, we have to substitute here n less than 0. Minus 1 substituting value is 2. Minus 2 substituting value is 4, minus 3 substituting value is 6, like that. So we got a pattern which is followed by fn and gn. Now you see that first of all fn is returning 1 for two different values of n, right? F of 1 is equal to f of 2. F of 1 is equal to f of 2. What does it mean? Fx must be a many to one function, many to one mapping. So f1 is a many to one. F is not 1 1. Of course, f is not 1 1. F is many 1. And so option D, if you see f is not 1 1, that is correct. F is not 1 1, that is definitely correct. But f is onto. Is f onto? What is the codomain of f? Set of natural number. If we see the value, you see that 0 is covered. And here negative numbers will be covered, negative integer, minus 1, minus 2. Next will be for 10, it will be minus 3. So minus 1, minus 2, minus 3, minus 4, all the negative integers will be covered. 0 is covered and positive integers are also covered. 1, 2, 3, 4, 5, next 6, like that. So all the integers are covered by the function f. So we can say that from here that f is not 1, 1. F is not 1 1, but f is onto. F is definitely onto function. Okay. So we can go with option number D. Option number D is correct. Next, if you see for G you see what is the codomain? For G the codomain is set of natural number. But clearly you can see the values returned by the G is here we are getting for the positive. For starting from 0, I am getting 3, 5, 7, 9, 11, 13, like the odd positive integers. And for negative n, I am getting 2, 4, 6, 8, 10, 12, that is even positive integer. So here we are having odd positive integers, 3, 5, 7, 9, like that, and here even positive integer. Odd positive integers and even positive integers. But 1 is missing, 1 is not returned by the function. So, Gn cannot take the value 1. Gn cannot take the value 1. That means the function G, range of the function G does not contain 1. That means G cannot be an onto function. G is not an onto function. So, here this statement is wrong. G is onto. This statement will become wrong because G is an into function. So, this will imply range of G is set of natural number except 1. Set of natural number except 1. But its codomain is natural number. So G must be into. So option C is wrong. Now you see that G is into function, right? G is not an onto function. If G is not an onto function, then definitely G of F, this is also not an onto function. If G is not an onto, then G of F cannot be an onto function, right? Because G of F returns values which are subset of the range of G, right? So G of F is not onto, this part is correct. And if you see the first part, that is G of F is not 1, 1, that is also correct, because G of F1 and G of F2 both will be equal only. G of F1 and G of F2 will be equal because F1 is equal to F2. F1 is equal to F2 equal to 1. That means both these value will be equal to G1, and that is nothing but G1 is 5. So G of F1 and G of F2 are same. That means G of F is not 1, 1. So option number 1 is definitely correct. G of F is not 1, 1, and G of F is also not 2 because G is not on. And option B, if you verify, FOG is not 1, 1. FOG is not 1, 1. Now if you closely observe F of G, now when function F is repeating its value, function F is repeating only the value 1, right? In the range, 1 is only getting repeated by the function. That's why it is many to one function, right? So if you see, it is repeating 1 for 1 and 2. Okay. So FOGN equal to 1. If we solve this equation, FOGN equal to 1. So F of Gn equal to 1. If I consider this equation, now here this Gn cannot take the value 1. Gn cannot take the value 1. We already know that Gn can never take the value 1. That means Gn can take the value 2. If Gn is 2, then F2 is equal to 1. That means there exists no such n value for which FOG can repeat its value. Because for FOG to be 1, then Gn should take the value 1 and 2. Then only the corresponding FOG value will be 1 and 1. Means F of G, say F of, when Gn will be 1, if Gn equal to 1, then that will imply F of Gn, that is F of 1, that will be 1, and when Gn will be 2, and that will imply F of Gn, that will be F of 2, that will be also 1. But Gn cannot be 1. That means F1 equal to 1 will come, function will return 1, FOG will return 1 only in one situation. So that means FOG is 1, 1 function. The only way FOG can be many one function is by repeating the value 1 in the range, which is not possible. So we can say FOG is not 1, 1. This statement is wrong. So option B is wrong. So correct answer is A and